in Hilo. Okay.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Hilo, and today I'm going to present a review paper on improvement on heat transfer using nanofluid through carrugated facing step. So this presentation is about using enhancing heat transfer using only nanofluid and geometry, which is a carrugated facing step. Here are the contents of this introduction, objective, the summary, and the proposal channel, and the conclusion. First, what is the nanofluid? Actually, it is a fluid containing a nanometer-sized particle called nanoparticle. The fluid are engineered colored suspension of nanoparticle in basic fluid. The basic fluids could be such as water, oil, and any else. And this name, the nanofluid, is conceived by Dr. Choi in Oregon National Lab. The nanofluid has a lot of application could be used. From this application, the electronic application, transportation, industrial, nuclear, space and defense, and chemical, and a lot of else. Here you can see in the picture the powder mixed with the liquid with the base fluid, and produce as the nano fluid. And this suspension could be in different volume concentration. From one of the nanofluid application which can be used, the heat exchanger, as you can see there. The heat exchanger is a device used to transfer heat between two or more fluids. There is several types of heat exchanger. Here is the shell and tube exchanger, which contains pipe, just a smooth circle pipe. Also to enhance heat transfer, as we mentioned, we can use nanofluid, and we could change the geometry shape. Like here they use the circle tube, and also other studies they use square tube, corrugate tube, facing step tube. You can see here down the facing step. The significant about using the facing step channel is that the sudden compression and expansion in the channels flow is very important. It's designed in many particle applications for cooling and heating system. Since this facing step cause a vortex generate, and that leads to enhance the heat transfer through the channel. The objective of this review are the studies and investigation consider fluid flow over corrugated and facing step channel, where still required considerable effort since it is not entirely understood. And this study is here to present an exclusive review of heat transmission enhancement through facing step and corrugated channel. Okay, so the research summary. There are two techniques to prepare nanofluid, which are the single step and the two step or the double step. The single step method is it will be done like by that the nanoparticles are prepared and suspended into the basic fluid. And the two-step method is done by nanoparticles are produced first. The nanoparticles are disappeared in the basic fluid using ultrasonic equipment as shown in this picture. The advantage of the single step as to minimize the fermentation and avoid the oxidal. However, most of the study they're using the two-step method or the double-step method, since it has low cost and it is appropriate for large-scale nanoparticle. There are many types of nanoparticle materials. Could be used and disappear in the basic fluid, such as Al, Ag, Fe, and also oxide metal and nitrate, ceramic, and else. So here in this figure we can see a different type of nanofluid, oxide nanofluid in different concentration, mixed with all of them with water, distilled water. And this graph shows comparison of thermal conductivity of graphene water with the various metal oxide nanofluid as a function of temperature. So you can see here different nanofluids show different number of thermal conductivity, which is the thermal conductivity is one of the most parameter that we're looking to improve in heat transfer. So there are many ways to measure the thermal conductivity, such as the transit hot wire, thermal and thermal constant analysis, the 3 omega and else. And here in the other graph, you can see the thermal conductivity for different material, and you can see that the thermal conductivity for solid it is higher than for liquid. Many researches are carried out to improve the heat transfer rate of basic fluid using nanofluid. So Mr. Lee, from his results, he gets 40% increase in thermal conductivity was found in CO oil-based nanofluid with 0.3 volume concentration. Another study using the Al2O3 with the water-based nanofluid, it's had 29% enhancement of thermal conductivity for 5% volume concentration. And another study using the TiO2 the heat transfer coefficient is 12% smaller than that of the pure water at 3% volume fraction. Okay, so here in these two tables, a summary for previous research on the nanofluid heat transfer in turbulent forced convective heat transfer and in the laminar. And it is clear that in the turbulent forced convective, the study for Mr. Bandy by using Al2O3 with water, and the type of the channel used the carrugated channel with 2 to 4 concentration get 40% enhancement in heat transfer. And in the laminar study, the study that doing using the laminar, we can see that the highest one for Mr. Putrajaya and that using the same nanofluid but with the flatted tube, and the enhancement was 28% in heat transfer. This table shows a previous study, also using previous experimental and numerical study using different type of nanofluids, and but all of them use the corrugated channel, and we can see they all get different number of enhancement in heat transfer. All right, here this is the proposed channel from the literature that we made. They use a lot of from the literature we found a lot of channels they propose and use on heat transfer. And from the recently study, they use the pacing step with the corrugated the pacing step with the trapezoidal. So the proposed channel will be adding a baffle to the geometry, and we believe that this bubble will gonna enhance the heat transfer since it will gonna increase more vortex. The conclusion, the research survey showed that nanofluid have a significant impact on heat transfer improvement. The understanding of the fundamental of wall function and heat transfer is very important for the development of nanofluid for a wide range of heat transfer application. However, there are recent development in the study of heat transfer with nanofluid. More experimental and theoretical study of particle movement are needed to understand the fluid flow behavior and heat transfer of nanofluid. So from this study we came up with 5 findings, which are there are no study focused on objective heat transfer by nanofluid for corrugated instead. And also the comparison being done between smooth and corrugated channels show that there was a significant enhancement in heat transfer by using the corrugated channel. Also from the nanofluid that we go through, there is no using for aerogel nanoparticle. The fourth one, there are no previous experimental study to discuss the flow and heat transfer over micro scale forward facing step using different type of nanoparticle. And lastly, during through the review, there's also summarized the recent research of heat transfer enhancement using nanofluid, the effect of several parameters such as particle size, particle shape, concentration, volume, and else on heat transfer were presented. The fifth one is not mentioned during the presentation, but it's there on the paper. And thank you very much. Who else?
Regarding with nanofluids, so you're going to use the nanofluids for a coolant structure. So most of the studies, they are using metal oxide. Okay, and I saw from your conclusion, seems like you want to use aerogel.
Yes.
So is it the type of like hydrogel or zero gel?
Sorry. Yeah.
Because if you are using only aerogel, it's type of a filler without the solvent. You say you want to use nanofluids.
Mm-hmm.
Okay, so it means that you need to add the aerogel inside the water.
Mm-hmm.
So it's called hydrogel, if I'm not mistaken.
Actually, I'm not sure about that. As I mentioned here, this happens being used. Okay, and that doesn't mean I will get used. I will do further study on it. Later on, I will decide if I'm going to use.
So you haven't decided which one you use. You just do some review study, right?
I just generally what's happening beforehand. And what is not.
So what do you think on the because this is a nanofluid, so the fluid should be stable in its the nano fluid should be stable in its suspension.
Yeah, sure.
Okay. So how long is it the stability? Do you think?
Okay, actually the stability will not can be include my my work, since I'm working now only on the heat transfer and increase the heat transfer enhancement, and for the stability it could be another work. The enhancement of the stability in nanofluid, it is a serious problem in using nanofluids nowadays, and there is like a specific study just only how to enhance the stability of
Because
the nanofluid.
I think it's important
Yeah, yeah, yeah.
So especially when the researchers using metal oxide.
Yeah, yeah,
So
yeah,
metal
sure.
in terms of its the weight is much heavier compared to the aerogel.
Yes, sure.
It can only be dispersed with presence of dispersant. It can be stable. Okay?
Yeah, for the result.
Yes, yes.
This could be stable more than the metals.
Mm. That's it. I think this is a good study.
Thanks.
Any more questions for Ali? We still have plenty of time in today's session. Anyone? No? Okay. Well, so for the kind of fluid flow that is being studied there, you introduce sudden step changes in the channel.
Buffalo.
Yeah. So that means that in the flow itself there are losses in terms of pressure.
Pressure drop.
Yeah.
Yeah. This will can be taken consider, and we will try to we will change the parameter of this bubble due to the amplitude height and the weight of this bubble until we get the minimum pressure using here.
Okay.
Yeah, this will be considered.
And then in your literature review, you mentioned percentage enhancements.
Yes.
So for each of those studies, they had some kind of a baseline or a benchmark. The enhancement, is it the thermal conductivity, or like what is the quantity that's being measured in the what is the
the enhancement is due to the missile camber.
okay.
Yeah.
All right. Thank you for clarifying. If that's all, let's.
Thank you.
All right. It gives me immense pleasure now to introduce the final paper. The title of which